Warning: I strongly advise against attempting to recreate the events posted here unless you know what you are doing. Carbon dioxide in its gaseous form is heavier than air. In its solid state it's called dry ice or hot ice. Precautions need to be taken in handling for risk of burns to the skin. It should be stored in well-ventilated areas, being a risk of suffocation by displacing air. Pressures may easily reach and exceed 900 psi, so containment units should be vented to eliminate risk of explosion. The lubricant used in AC and refrigeration systems flow through the circuit and must be able to be dissolved by the refrigerant. When changing refrigerant, the lubricant sometimes require changeout due to compatibility issues. A popular example is R22 using mineral oil and R410A using polyester oil. In removing oil residue from a system, a solvent and propellant is used. There are various solvents available as flushing agents to remove oil residue. In respect to my other video, flushing an air conditioner lines for a conversion from R22 to R410A, I did say carbon dioxide is a viable method I would be trying. Carbon dioxide is in fact a refrigerant known as R744. It is compatible with all of the lubricants used in systems. Using it as a flushing agent would not require a solvent, as liquid carbon dioxide functions as both solvent and propellant. I picked up 2.5 feet of 2-inch carbon steel pipe with threaded ends and end caps from SSL Trinidad and Tobago. The pipe is rated for 3000 psi and end caps rated for 6000 psi. A cap was drilled and tapped to accommodate a 1/4-inch stainless steel SAE fitting and yellow jacket hoses used that can safely handle 800 psi for testing. Loctite 5113 was used around the threads for sealing and pressure testing. To minimize wastage, 150 psi of gas was filled into some empty refrigerant tanks for storage to clear condensate lines. Do not, I repeat, do not attempt to do this at home. It was only done after intense research on tanks and safe pressures for them. With the containment unit filled, pressures reached 800 psi easily and was released. Keeping the mass under pressure allowed it to change phase into liquid. Venting through the stainless steel fitting at 150 psi provided a mixture of pressurized gas and liquid. The manifold gauge hoses are 5 feet each, so it seems the liquid had already changed phase into a dry gas even at 600 psi in initial tests. A fitting was brazed onto a condenser coil to see what was the result of sending pressurized CO2 through it. With the containment unit almost empty, all that went through was dry gas. Most systems can handle over 150 psi safely, so introduction of liquid and gas at such pressures should be safe. Another challenge is water vapor from the air freezing and blocking lines, so lines may require purging prior to flushing. In order for it to be successful, a pressure release valve will be added for safety and a gauge attached for monitoring internal pressures. A shorter length of 1/4-inch steel braided line and female SAE adapter at the end with a valve is a viable option for prevention of phase change prior to entry into the system.